Hey guys, it's me again. I am going to go over the multiple choice answers for topics 1 through 3. So if you're having trouble kind of like thinking through the questions, I'm just going to kind of go over it with you. Okay, so let's see, we'll do this one down here. Okay, so the first question asks you about the electron configuration of Mn plus 3. So you would first want to write the configuration for just Mn in the ground state. So it says it's number 25. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Okay, so to do Mn plus 3, the 3 electrons are going to be lost from the highest energy level. The highest energy level is 4. So even though it's kind of tucked in right here, it's still a 4. So you're going to get rid of these two completely, so that would be a plus 2. And so the third one will come from the D. So the answer to that one is A. Okay. In 2, to decide which ones are paramagnetic, paramagnetic means it has unpaired electrons. So if you go through and you look at where each of the things are, you'll notice that V, vanadium, CO, cobalt, and Zn, or not Zn, Zn has 10, okay, and As are all odd numbers. So they are going to be the ones with unpaired electrons. Ca is a 4s2, Ca. Zn is 4s2, 3d10. So these will just be, all the electrons will be paired. Okay, so that one is letter B. Alright, number 3, J.J. Thomson did the electron. 4, you guys seem to have trouble with these, so let's talk about them. So, let's see, these are our options here. You can't really see this very well. Okay, I already have the answers down. But an impossible electron configuration is going to have something like 1p or 2d, 3f, that kind of thing. So if you look at your choices, choice C here has a 2d sublevel. You guys should know that 2d sublevels do not exist. Okay, for number 5, ground state electron configuration of a transition element. So transition elements have to have D. Obviously can't be one with a 2d because that doesn't make sense. So it's either going to be 3d5 or it's going to be 3d3, 4s2. So ground state means that all the lower energy levels are full first. So in this one, 3p6, 3d5, you're missing your entire 4s. So this one has to be an excited state. So the answer is E. Alright, for 6 and 7, what I would do is just kind of like pick a halogen or pick a, so for C, 5E. So for 6, I would look at like fluorine, for example. Fluorine is 1s2, 2s2, 2p5. Its ion, -1, would be 1s2, 2s2, 2p6. So you're looking for any halogen's ion is going to end in a noble gas configuration. So the answer to that one is B. Same thing with your alkali earth metals. So let's say you have 1s2, 2s2, 2p6, 3s2. Its ion would be +2, so you'd get rid of these, and so it would be letter B as well. Okay, question 8. Can be used to predict that a gaseous carbon atom in its ground state is paramagnetic. So paramagnetic is based on unpaired electrons. So C, Hund's rule, is the one that's going to help us figure out if they're going to be unpaired. So like if you have 3p3, it'd be up, up, up. Versus, or if you had like 3p4, it would be up, 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 down, instead of having both of them paired. So Hund's rule is the thing that helps you figure that out. 9, experimental phenomenon of electron diffraction. Diffraction just means like it's going to split into waves. So that's going to be your wave nature of matter. For 10, indicates that an atomic orbital can hold no more than 2 electrons. That's Pauli. So Pauli exclusion principle said that you can only have 2 electrons per orbital, 1 up and 1 down. Okay, 11 predicts that it's impossible to determine spontaneously position and velocity. That one's going to be Heisenberg A. Alright, and then 12. So 12 is the only one that might be tricky. So it says the quantum numbers for the highest energy electron in gallium. So if you write gallium's configuration, your highest energy electron is a 4p1. N, L, M sub L, M sub S. Okay, so when you're doing quantum numbers, N is represented by the energy level, 4. Anytime you have an L, it can go from 0 to L minus 1, or to N minus 1, sorry. But whenever you are given the sublevel that you're in, an S is 0, a P is 1, a D is 2, and an F is 3. So this is 1. M sub L can be negative L to positive L. So it could be 1, 0, negative 1, any order. And then M sub S is plus or minus 1/2. So if you go through and look at your choices, you end up with choice C. Okay, topic 2. Alright, so let's see, number 1. Alright, so you guys know the trend for ARM and ENI. So ARM gets bigger going down and smaller going across. Okay, so if you check out where these are, so BE, B, C, and N going across, they go down. So choice A goes down. Choice B is on a diagonal. So even though it's going across, it's not going to get smaller because you're going down energy levels. So this one will go up. Choice C, noble gases, so you're going down a group, so those will increase. Let's look at choice E. Magnesium, calcium, barium, that's also going down a group, so that increases. And then you have choice D, which are transition metals going across. Transition metals are not going to have significant changes in atomic radius because you're adding electrons into a D sublevel, which is kind of like inside and there's space already there. So it's going to change slightly, just not a whole lot. So D is our answer. Alright, 2. Most electronegative atom is closest to F, so that would be O, oxygen. 3. Which element exhibits the greatest number of oxidation states? Oxidation state means charge, basically. So you want to pick a non-metal because they can be positive or negative. The ones that have fewer number of valence electrons can have more options for charges. So that one's going to be E. 4. Which of the elements above has smallest ionic radius for the most commonly found ion? Okay, so we have, let's just write some O minus 2, N minus 3, Mg plus 2, because we're working with ions. I'm going to ignore La and Rb because they're low on the periodic table as it is, so they're going to be larger regardless of their ion. Alright, so I'm going to count all my electrons, and I end up with 10 electrons here, 10 electrons here, 10 electrons here. Whoa, what do I do now? Okay. Check out protons. 8 protons, 7 protons, 12 protons. So the question is, which one will be smallest? So if you think about the nuclear charge as your number of protons, which one of these can actually pull in electrons the most? And that is your Mg. So that answer is D. Okay, I'm going to flip this also. Okay, let's see, question 5. Question 5, going across, what happens to radius? Just know the trend, D. 6. Okay, so for 6, these are the values given for your ionization energies. Okay. Easy, here to here, easy, easy, whoa, really hard. So when it gets to the whoa, really hard part, that means you're starting to remove core electrons. So it was able to lose 1, 2, 3 electrons before gaining a stable octet. So it means you have 3 valence electrons, which would be a letter E, Al. Okay, 7. This is just kind of like a weird question if you look at it. What I would do is kind of go through and just eliminate what you can. So choice A, first ionization energy decreases as atomic numbers increase. That's true. B, fluorine is best oxidizing agent, means it gets reduced. So if you think about reduction is gaining electrons, which means it would be highly electronegative, which is also true. C, fluorine has the smallest radius, true. D, iodine liberates, I'm like, what the heck is that talking about? So I'm going to skip that. So E, fluorine is the most electronegative, that's true, so this has to be your answer, so D. Okay, topic 3. Oh no, the batteries might die. So if I get cut off, it's the battery. Okay, topic 3. You have 214, 84 Pu. Okay, so as you go through an alpha decay, 4 to He. So figure out your missing piece here. So 214 minus 4, 210, 82. The numbers don't really matter right now. Okay, so we're going to take this, and it says we're going to go through 2 beta decays. So you can do 2, 1, 0, or sorry, that's a neutron. 2